Hi, this is Grant Taylor from RevitWorks, and I'm going to show you how to build a simple family using parametric techniques. And we're actually going to look at what I call the skeleton framework technique, a technique that will uh, should be the basis of all families that you create. It's everything works well this way. Families don't tend to break when you use the skeleton technique. And we'll go through with you how all this works. So first of all, we'll start a new family. And one of the first things you have to choose is a template to work from. Now, as you produce more families, these templates will become obvious. There's a template there for pretty much every kind of category that you want to do. If you're unsure, start from metric generic model. It's not a bad one if you're not really sure where it is, but also from here you can turn it into any one of these anyway. So that's where I'm going to start here now, metric generic model. And this is what we get. What we're seeing here is basically the default floor plan view, what it would look like when you put it into a plan view in your Revit project. And the family template gives you several preset views. We're probably going to use most of them. But let's start at the beginning here. This is your family category and parameters. So you shouldn't really leave things as generic models. You really choose which category it lives in. And you can change a family to one of these categories, pretty much any one of these categories at any time. So we are going to make a table here. So it's going to be a piece of furniture. There you go. We could have got to the same place by starting um, a, a, a family from the furniture template. So the first thing we're going to do is set out the framework of our table. And we'll start thinking about the tabletop. To do this, we use reference planes, not reference lines, but reference planes. So reference planes are always the dashed green lines. The reference line is a solid green line. So I'm going to put one down here for the left-hand side, one for the right-hand side, one for the back, and one for the front. Now this table is going to, when we change the size of the table, it's going to grow or shrink from the middle. Um, so that's how we're going to put our dimensions across. So go to the Annotate tab, put aligned dimensions on, click on all of those three, and we'll equalize that out so that it's going to grow equally from the middle. Same, we'll do those horizontal lines, equalize those out. And then we put another controlling dimension across the top and down the side, and we'll turn these into parameters. So if I select this one here, we go up to the label tool on the ribbon, check the down arrow there. There are no pre-built parameters. Some templates give you pre-built parameters. This one doesn't. We have to create one. So we click on Create Parameter. And here we're going to make one called the length. Now my standard rule of thumb is I always type it in capital letter, lowercase for the rest of it. And this will be a type instance. Sorry, a type parameter, not an instance parameter. And we'll do the same for this one. We're going to create this to be the width. So again, create a parameter, call it width. Capital W-I-D-T-H. Now, it doesn't actually matter how you spell that or create it or what case you use, but you do want to lock in on a consistent formatting. Like I say, my consistent formatting is always a capital W and then lowercase for the rest of it. That becomes important when you get a bit more complex on your families and you use parameters and formula, in which case you have to type them out, and you have to type them out the way they were created. It's case sensitive, so I always create them the same. Some people use all uppercase, some use all lowercase. It doesn't matter, just make it consistent. Now, you always want to check that these things work. So we're going to quickly flex our model, and you can do this in several ways. If I click and drag one of those reference planes, see how the other side is expanding out. or contracting. That's great, that works. And the same here, so I'm just clicking and dragging here, so my equalizing is working. And also, if I click on this parameterized dimension, I can click on the word length and give it a value, let's say 3 meters. And the reference plane's closed up, so it's working. It's a good idea to always flex your family a lot. Let's make that 1500 and it's working. So you don't want to assume that you're putting the parameters in correctly. Again, at this stage, it's really simple, generally works. But when your families get a bit more complex, sometimes you pick on the wrong things, sometimes you type something in wrong. You want to check that the parameters are behaving as you intend them to all the time. Okay, so that's the top done. Let's go to the front elevation and we'll put some height parameters in. So on my south elevation here, I can see I've got a reference level. So again, when we load this into a project, we'll be putting this table on one of our floor levels. So that's what reference level means there. But there is also a reference plane hidden under there. I'm going to hover over there, use the tab key, and see how there's a reference plane. So there's a reference plane on top of the reference level. Now that becomes important. We want to be dimensioning to the reference plane as much as possible. So we'll come to that shortly. I need to put in another reference plane for the height of the table. And I'm going to put another one in for the thickness. And notice here that I'm just placing these reference planes anywhere. Certainly the underside of the table is below the top, but I'm not worrying about the heights here yet. In fact, whenever you're modeling or creating families in Revit, you're generally trying to make them the wrong size and then push them back to the correct size at the end through their parameters. That's another great testing. But also, if that tabletop was really thin, then that reference plane had to be sort of up there. That's just harder to work on when they're close. You may as well make life easier on yourself. Put it back there. So again, I need to put some parameters on for the height. So again, it's an align parameter going from the top. And this time, I want to make sure that I get to the reference plane that's hidden under there, not the reference level. So that the reference level is coming up there. I'm going to hit the tab key and make sure I get the reference plane and dimension to that. Now, it's not critical that you do that. That just allows a bit more functionality later on. That's going to be the height. So again, I'll create a label on that and call that height. And again, it'll be a type parameter. Now you decide how you want to control the tabletop thickness. Do you want to lock it in as a set dimension, or do you want to control the thickness of the tabletop? Either way, you do need a dimension. So we're going to have to place a dimension on here. Now, if you want to lock that in at a distance, make sure you dimension it and padlock it. That means the tabletop will be, well, 500 mils. You do have to dimension your reference planes off each other. If I leave that unlocked, potentially I could move the top below its bottom, and that's not a good thing to happen. That will break the family. So we want to make sure that when we move the top, the bottom goes with it, and you can do that by parameterizing it, and by locking a dimension. Or if I unlock that, I'm going to turn that into a parameter so that I do have the control of changing its thickness. So we'll call it thickness. And again, that'll be a type parameter. Okay, so once again, we test all these parameters. We flex our model. Let's click on that, change that to say 1200. Yep, things are moving as I expect. Change that to, let's say, 200. Yep. Eventually that's going to become something like 720 and then that'll become 40. But at the moment, that's nice and easy to work off. So we've done setting up our reference plane skeleton. We might put some more reference planes in later on to control the leg position, but these are what we need to model the top. So I'm going to go back to the floor plan view and start modeling the top of our table. So again, on the Create tab, we've got these basic forms that we can model from: extrusion, blend, revolve, sweep, and sweep blend. And then we've got the void forms of those as well. So out of all these form types, we can pretty much make what we need. Have a look in the help of all of these. You'll see what they can do and what you can use them for. I'm simply going to make an extrusion here. It's going to be, I'm going to define the shape of the tabletop and plan, and then extrude it upwards to give it a thickness. So here we go. Let's make an extrusion. We're back into sketch mode here now. Now I'm going to show you a few tricks what happens when we put this pink sketch line mode in. So here we go. Because it's a rectangle, I'm going to snap onto the intersection of those reference planes and click on here. Now at this stage, all these padlocks pop up, but you don't actually need to click on the padlocks. Let's prove that. If I click on there, and if I move one of these reference planes, see how the extrusion automatically stuck onto that reference plane without me padlocking it. So let's go back and I'm going to select that extrusion, edit the extrusion. We're back into these pink lines. So I'm just going to delete those out. I'll hover over one, hit the tab key to select all of them and delete them. I'm going to put that in again. Look what happens if I don't click on the reference planes, just near them. Move that. See how that extrusion is still somehow linked to those reference planes. Now that's a bit of Revit black magic going on there. There's no rhyme or reason why it would do that. We didn't padlock anything, we didn't trace over anything, yet Revit is still associating those pink lines to those reference planes. Let me go edit that extrusion once more. And if I put that one, say, further away, let's see what happens. All of a sudden that one's not attached to that reference plane, but this one is. But if I move this one, I can't, it's pinned. I'll unpin it and move it. See what's happening there. So Revit is actually locking those reference planes to, locking the pink lines to the closest reference plane that it finds automatically for you. Let's push pin that again, edit the extrusion here, just sort of move it back. And it's worthwhile knowing that Revit does this, so you don't need to padlock the pink lines all the time. Typically, if you're tracing a pink line over a reference plane, it's going to stick to it. So it's only when you get complex on your families and you might need to differentiate which reference plane that pink line should be sticking to, do you really need to padlock those reference planes, those pink lines. If in doubt, you can. So don't forget, align and lock also works. So if you want to be absolutely sure, you can align, lock, and padlock. And actually, that's a good way of fixing up things that somehow get broken on more complex families. Let's do that. And flex the model once again, just to check. Yep, it's working. So in plan, our tabletop extrusion is working. Let's go to the front elevation. So when I put that extrusion in, I didn't really care about the height of it. Now I do. I want the top of the extrusion to be onto that reference plane. Now you got to be careful here. I'm moving the top of that extrusion up by dragging the little wee shape handle. So I'm clicking on that arrow, dragging and dropping it onto a reference plane. And see how I can see that reference plane highlighting? Then you know it's on it. Then you've got to padlock it. Don't forget to padlock. Let's do the same for the bottom. On to that reference plane and padlock. Then we test it. Change the height, it's working. Change thickness, something random, it's working. Quite often people forget to do that padlocking. If it doesn't work for some reason, and I'm going to break that association with the reference plane. There we go, remove the constraints. You could also align and lock the bottom of that extrusion onto the reference plane. That's another good technique as well. So aligning, select the reference plane, the bottom of the extrusion, and padlock it. And that's all good. So now we have, in 3D, a tabletop. Okay, at this stage, that extrusion is just a lump of something. We haven't given it any material at all, so we can't control whether that's going to be glass or timber or whatever. So that's where we go and put a material onto it. But in the family editor, you don't generally specify the materials unless you want to lock it in and keep it that way. And also in the family editor, you've got a pretty poor selection of pre-built materials. And actually, the materials you probably want are the ones that you've defined in your project, which you can't actually access in the family editor. So very rarely do we sort of hard code in a material at this stage. What we do is we put a material parameter on it so that the material can actually be specified when you've loaded it back into the project. You do it this way. Instead of clicking this materials button here, you click the one over here, associate family parameter, and we create a parameter for it. You've got no material parameters to select from yet, so we have to make one. And I'll call this tabletop. Again, we'll make it a type parameter here. So we haven't said whether it is glass or timber or anything. We've just said this extrusion now has a parameter that can be filled in for the material when it's back in the project. So that's step one. Now we have to go make the legs. Now you could just do simple extrusions for the legs. Let's say we just want some fairly simple round legs going from here. And if I go to the front elevation again, I could drag and drop that on to the reference plane. You've got to remember, I don't want it to the bottom of the extrusion. I want it to the reference plane, because the reference plane controls the underside of that tabletop. It is possible, actually, if I tab around, to connect it to the bottom of the table, although it's not letting me this time. But that's good. I don't want to. I want to get the reference plane. So the top of the leg is associated to the reference plane, and the bottom of the tabletop is associated to the reference plane. That's sort of the best, purest sense it can be. Padlock that. Now that's easy. Now we could have made an extrusion of 4 legs, or I could copy this extrusion around. But what happens if it's a complex leg? Very easy to do simple extrusions like that, but if it's a complex form, that gets very hard to replicate anywhere else, and also means that you can't replicate it in other families, or you can't use that complex leg in other families. So you might have a round table that you want to do later on and use the same leg in it. If you model the leg straight in here, it can never be used anywhere else. So I'm going to delete that out and not use that, but start a new family for the leg. So here we go, we'll create a new family. Again, metric generic model. Or I could have chosen the metric furniture. I'm just going to change it to furniture here. And let's put, again, some reference planes in there controlling what needs to be controlled. Now on this one, I certainly need to control the height of the leg. It's got to go from the floor to the underside of the table. So I need a reference plane representing the height of the leg. And I need to parameterize that. So again, exactly the same as we did before, a line dimension from the top reference plane, not to the reference level, but tab through and get the reference plane there. And we'll turn that into a parameter and we'll call it height. You could call it leg height or whatever, but it's going to be a leg anyway. But on this one, we typically make this type of family an instance space one, because each leg might need to be a different height depending on exactly where we're putting it. So we OK that. Now I am going to make a leg that is not a simple extrusion. We'll do something like a blend where it can be round, certain diameter at its base. Let's just make it about 30 mils radius at the base, and at the top we'll make it just a bit bigger. And if we have a look at that at the front elevation, there we go, nice tapered round leg. And again, I can drag the top of that onto that reference plane and padlock it, so that if I change the height, it's extruding. Now, you don't have to worry about what the height is here. Again, that's going to be defined when we use it in the tabletop. But we do need to specify a material parameter so that we can give that leg a material later on. So we'll do the same thing here. I'll make a new one, and I'll call this leg material. That could be type or instance, depending on whether you want all the legs to be the same material or have the ability to make all legs different. I'll just make it a type parameter. Okay, so we need to load this into our tabletop family. So I'm going to load and close it in. I don't need to save the changes. It's going to be called family 2, but I'm going to rename it later on. So I don't want to save it. I just want to load it into that family. And now it's asking me to position it. So look, I'll put one around about here, just for the meantime. We'll position it accurately next. But before I go too much further, that is just called family 2. Let's go down in the project browser, find that, and rename it. Something a bit more descriptive. Tapered leg. And actually, I'm going to give the type name the same name. Yeah, just copy and paste that in. That's a quicker way of naming your families rather than saving them to disk before loading it in. Okay, let's go to the front elevation and deal with the height. So the height of this needs to be the underside of the table. Now, there's two ways of doing this. See how, because it's an instance parameter for the height of the leg, it's got a grip on there that I can drag it up and down, which means I could drag and drop that onto that reference plane and padlock it. That's valid, but it's not actually the best way. I'm going to now introduce you to a simple formula which if you use formula in your families, it's a much safer way of creating complex families. So let's start off on the right tack here. The height of this leg is actually a formula that is the table height parameter, minus the thickness. So we're going to make a new parameter called leg height, which is driven by a formula, and then assign it to this family. So to do that, we're going to bring in this tool, family types. And actually, just before I do that, I'm going to pan my drawing off to the side here and just rearrange this so that we can see what's going on here. Now, here are all my parameters that I've made, and you can actually change them here. Let's just check this. We'll adjust the height, apply that, see how the height's changed. Adjust the thickness, apply that, and that's all working. So this is a great way of flexing your model as well. But what we need is another parameter in here under dimensions called leg height. And I get to make one here. New parameter, leg height. Now, because all of these parameters that we've made here are all typed, parameters, we can make this a type parameter as well. But instead of typing in a height, I'm going to use the formula. And this is where the way you've spelt, or the case you've used for your parameter names becomes important, because you just type it in exactly as you would say the formula. It is height minus thickness. Notice I spelled thickness there wrong. I better fix that one up, but I'll do that later. C-H, that should be K-N-E-S-S. And if you just click into any other field here, it will apply it. And see how it's calculated the leg height. And it's grayed out because you can't specify that manually. It's driven by a formula. Now, just while I'm in here, I'm just going to click on that, hit the edit button, and change the spelling of that parameter correctly, thickness. Notice how that's all worked its way through, and that's great. So we go OK to that. Now, if I select this leg here, on its properties, because we made an instance parameter, there is the height there. So I could type it there and change it. 600, apply it. Or, and this is what we need to do here, associate that parameter to another parameter. So the height of the leg actually equals that parameter we just made, leg height. There we go. And that's correct. So it's driven mathematically. So again, we'll flex our model, change the height here to 1 meter. Everything's working through mathematically. So if you can drive nested families, as we've done with this leg, their parameters through formula rather than dragging and dropping them, trying to padlock onto reference planes or other geometry, you have much better success in complex families. So now we need 4 tables, 4 legs. Oh, actually, I've just remembered we need to look at this material as well. Where's that material parameter we made here? So at the moment, if I edit the type in there, I'll see that leg material that we made. And again, I don't want to specify what that leg material is in the family editor. I want to be able to do that in the family. So I've got to hook this leg material parameter through to another parameter in the tabletop family that can then be used in the project. So there's associate family parameter. If I want the leg to be the same as the tabletop, I can reuse that one, but I'm going to make another one called leg material. This will be type-based as well. So I've associated the leg material parameter in the leg family through to a leg material parameter in the table family, which can then be used in the final project. Now, if we go to our floor plan, I can now copy these legs around. We need 4 of them. Let's use multiple copy. There. Now, at the moment, the position of those legs are just as I've put them. They're not responding to any reference planes. So if I want all those legs to be positioned according to the tabletop size, I better put some parameters in. Now, there's several ways of doing this. We could just use dimensions and say, I would never tend to dimension from an extrusion handle. I would tend to go from a reference plane to one of the reference planes buried inside that leg. And I can push that around. Let's say 200. See how that's working there. Let's do another one here. Reference plane to the reference plane there. And now if I want all those equidistant around there, instead of telling them to be 200 and then having to padlock them all, which is a valid way of doing it, but when I want all of those legs to all be 200 mils off, That's a hard way of doing it. And also it's not changeable. What if somebody says they need to be 300 mils off? What we should be doing is parameterizing those. So I'll unlock those, change that dimension to something off here. No, there's no parameter there. I need to create a new one called leg offset. Again, it'll be a type parameter. But we can reuse these parameters. So that can be leg offset as well. Oops, wrong one. Leg offset. Which now means I've got flexibility over that leg offset. If I decide they need to be 300, yeah, they're all moving. So now I could go and position all of these legs the same way. Just align dimensions there, 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 change it to leg offset. But another way that is equally valid but might be more useful is let's draw some reference planes in for where the legs go. Now, if I just get rid of those, I'm going to align and lock my table legs to the reference planes. Reference plane out of the leg, padlock. Do the same here, padlock. Now I just need to dimension up my reference planes. Now all of those 4 dimensions can be that leg offset. And that's going to work. So 2 different ways of positioning the legs, all using parameters, but I would tend to go the reference plane way because you might want to use those reference planes for something else later on. So just double checking that I've set all the parameters right for all those legs. I'm going to grab all of them. I've got 4 legs chosen. All the heights are controlled by that leg parameter because I set it once and then copied it around. That's really all that needs to happen there. Let's go into our 3D view, have a look at our table, and do one final check with the family types. And this is where you say, right, the table's pretty much done here. Let's set it to our default heights. So when we first use this, we'll load it into a project. What would be the default set of dimensions that we want to use? I'll make it 760 high. Apply that, that's working. I'll make the thickness, say 40 mils. Let's make the length 2200 and the width 900. Apply all those, and that's all working as we need. Probably the leg offset's a bit too much, so we'll make the leg offset 150. That's looking better. There we go. Nice parametric table. So now we need to check that it's going to work correctly in a project. So I'm going to quickly create a project. Go back to that table family and load it into the project and position it. Now, at this stage, it is called family 1. It's not called table or anything. It needs a decent name. So you could either rename it here in your project. There it is there, family 1, similar to how I did the desk leg. Or you could go back into your project and just go save as and save it out somewhere on your disk before you load it in. But because I've already loaded into a project here, I'm going to rename this as table. And then I should really give the family type a bit better description of the heights or the parameters that I've set. It is 2200 by 900. That's not a bad description. Now let's just go to the 3D view quickly. See what's going on here. So this table, if we edit the type, we can now go through and define the materials. So let's look at the tabletop, grab a material out of here. I'm going to make it there'll be a wood material in here somewhere. Wood, teak, dark, polished, that will do. And we'll make the legs, we can make the legs the same. Because that's, so in the project we specify the materials. Now very easy, if I create another one of those, I can duplicate that up and maybe call this glass. In which case the tabletop could be glass. Whoops, click in here. So same family, different materials because the materials have been parameterized. Now, just one more thing that's quite important to understand about families. I'm just going to put some walls in here. Because at the moment, this table can only go onto a level or a floor, a horizontal surface. Now, because I've renamed this family in the project, the family that I first created here is still called family 1, so this serves no purpose anymore. I need to close that one down. Don't need to save it. But if I edit this family, I'll be editing the family called table. Now, this table, if you have a look at its properties here, must always be vertical and it's going to go onto a level. But if we tick that work plane based and unticked always vertical and then load it back in, I'll load and close, I don't need to save it. When I place that table, I can choose to place it on a work plane, which is the level we've done before, or on a face. It can go anywhere we like. And that's quite an important factor to understand about families. Some are restricted to only be horizontal, but what if you do want to place a table on a wall or a sloping surface or something else? Or actually, that table can go on any surface now, just by changing those two tick boxes, making it work plane based and not vertical. Now let's just have a quick look at the difference between type parameters and instance parameters. So on this table, we made most of the parameters type-based, which means if you want a table of a different size, you edit the type, duplicate it up, give it a different name, and change the parameter values. But we could make some of these parameters instance-based. Let's do that now. Once you see it, you'll explain what's going on. So we edit a family. If we go into the family types within the family and have a look at these parameters we've made, you know they're type-based because it just gives you the name that you specified for them. But let's say I want to control the length and the width of every table individually. I want to make it instance-based. Easy to do. You just select the parameter, edit it, and turn it into an instance. And then you get the word in bracket default after it. That's how you know whether it's a type or instance. That's an instance parameter because it's got default after it. Let's change width to the same, turn it into an instance parameter there. So quite often when you're making families, you don't know should it be type or instance. So it doesn't matter, you can always change it later on. So we apply that, OK that, load and close, back into the project. I don't want to save it there. Overwrite the existing version. And now that means, well, go to the plan, we can control each of these tables separately.